Tired of manually converting JSON timestamps and UUID strings into real Python objects every time you call an MCP tool? You'll see how FastMCP 2 automatically reconstructs complete Python objects, like data time and UUID, from server responses, so you can work with native types instead of raw strings. We'll compare the hydrated objects with the standard JSON output to show exactly what you gain.
From datatime, import datatime. From UUID, import UUID. Async with client. Result equals await client, call tool, get weather, city, London. Hash FastMCP reconstructs complete Python objects from the server's output schema. Weather equals result data hash, server-defined weather report object. Print F temperature, weather temperature degrees C at weather timestamp. Print F station, weather stationed. Print F humidity, weather humidity %. Hash the timestamp is a real data time object, not a string. Assert is instance, weather timestamp data time. Assert is instance, weather station ID, UUID. Hash compare with raw structured JSON, standard MCP. Print F raw JSON, result structured content. Hash temperature, 20, timestamp, 2024-01-15T14-30-00Z, stationed, 123E4567. Hash traditional content blocks, standard MCP. Print F text content, result content 0 text.
This demonstrates schema-aware RPC hydration, where raw protocol data is automatically reconstructed into native Python objects. The pattern bridges the gap between serialized network payloads and typed application code, letting you work with datatime objects, UUIDs, and custom classes instead of JSON dictionaries. What makes this distinctive is the seamless conversion from wire format to runtime objects without manual parsing or wrapper classes. The approach works by combining protocol metadata with Python's type system. When a tool call returns structured data, FastMCP consults the server's output schema to reconstruct complete objects, converting ISO strings to datatime instances, UUID strings to UUID objects, and nested structures to custom classes. This happens transparently during the data property access, while still preserving raw JSON access via structured content for interoperability. This matters because it eliminates the tedious boilerplate of manual serialization. You avoid writing custom parsers for every API response, reduce runtime type errors, and get immediate access to rich object methods. The trade-off is requiring server-side schemas, but the productivity gain is substantial for type-heavy applications like data processing, financial systems, or anywhere you need strict data contracts. Let's break it down.
From datatime, import datatime. From UUID, import UUID.
Imports datatime and UUID for type validation. These ensure the server's reconstructed objects contain proper Python types, not just strings, so you can directly use methods like datatime now or UUID, int, without manual parsing. This is FastMCP's zero boilerplate type safety in action.
Async with client. Result equals await client, call tool, get weather, city, London.
This invokes the getWeather tool asynchronously through the FastMCP client. The context manager handles connection lifecycle automatically, ensuring proper cleanup after the call completes. The dictionary argument, city, London, maps directly to the tool's schema parameters, demonstrating how FastMCP bridges Python types to AI-callable interfaces.
Weather equals result data hash, server-defined weather report object. Print F temperature, weather temperature degrees C at weather timestamp.
FastMCP automatically reconstructs complete Python objects from the server's schema. The weather variable is a strongly typed weather report instance, not raw JSON, enabling direct attribute access and proper type checking. This eliminates manual parsing and validation, while preserving the server's data structure exactly as defined.
Hash the timestamp is a real data time object, not a string. Assert is instance, weather timestamp data time. Assert is instance, weather station ID, UUID.
These assertions verify FastMCP's automatic type reconstruction. The server returns raw JSON, but FastMCP converts it back to native Python objects, data time for timestamps, and UUID for identifiers. This eliminates manual parsing and prevents type-related bugs in your application logic.
Hash compare with raw structured JSON, standard MCP. Print f raw JSON, result structured content. Hash temperature, 20, timestamp, 2024-01-15T14-30-00Z, stationed, 123E4567.
This demonstrates the raw JSON output from standard MCP, showing how FastMCP transforms it into proper Python objects. The string-based timestamp and UUID in JSON become native data time and UUID objects, eliminating manual parsing. This direct comparison highlights FastMCP's automatic type reconstruction advantage.
Hash traditional content blocks, standard MCP. Print f text content, result content 0 text.
This demonstrates standard MCP's backward compatibility layer. While FastMCP reconstructs objects, traditional MCP returns raw content blocks, here accessing the first block's text content. This dual-mode support enables gradual migration from legacy MCP systems. FastMCP object hydration. The data property transforms raw JSON into fully typed Python objects, reconstructing complex types like data times and UUIDs automatically from server schemas. Fallback to content blocks when schemas are absent or deserialization fails, but prefer structured data where available. This pattern eliminates the impedance mismatch between JSON and Python's type system.
The data that arrives as nothing becomes everything.